Well, hello and welcome. So in this presentation, we'll show you how AI can actually make the Paris real estate market more transparent by predicting values, identifying also like unusual things that can happen, like listings, and also revealing prices patterns across the city. So we are JV State. So we'll first present our team roles, then the business problem or solution, the data strategy we use, how and by whom can our solution actually be used, and at the end we'll finalize with a small conclusion. So
hello, my name is Apolline Léger. I was the business and strategy lead during this project, so I made sure that the success goals were hit, so the 10% error was met. And also I was responsible to see how can our solution be used and by whom. So this will be the last part that I will be presenting.
Hello, everyone. So my name is Jules. I was the main data and presentation lead. So I was in charge of the main data program and the main model we created. So this included everything from finding the data sets to realizing the model.
And hi, my name is Valentina. I was in charge of choosing the right regression model, this to be able to validate it properly and making also sure that we have the fair predictions. So just to getting started, we need to know our business problem. So what is our business problem? Is a market full of uncertainty, but also asymmetry. So we need to know that, of course, you kind of maybe know already Paris and that the real estate market there maybe looks active, really sophisticated as Paris is, but in reality, it can be really, really confusing. So this means that prices can change a lot from one street to another. There can be a lot of different type of prices. There's no way to really be sure how to compare all of this. The information, there's a lot of information across multiple platforms, so you don't even know where to look at it. For maybe people who are coming from abroad to Paris, like to buy a new apartment or just to move there, they don't know what fair prices are. So this can be really a big problem for people like you or people like even me or people or investors or just even like the government. And also we're talking about Paris, that Paris has in France complex laws like the loi Carrez. I don't know if you know it, but the loi Carrez is it's illegal to rent or sell something less than 9 square meters. So this actually adds a lot of uncertainty in the real estate market in Paris. Then if we're talking about what's wrong with today's valuation methods in Paris, you need to know that most property valuations still rely on everything that's human judgment. So you as a human being, you'll say if this is okay, this is not okay, maybe the price is really high or maybe the price is really low, but you won't be able to have a concrete say in anything. This will lead to a pricing difference, maybe a delayed decisions because you're actually looking to a lot of data on your own, and it'll make everything more confusing. So you'll have a higher risk of overpaying or maybe just paying for something that has no value in it. So we're talking about that. Valuation results can actually change depending on who does them, depending on the sites you're actually looking for. There's no real-time way to actually check the surface accuracy or legal compliance. Maybe an apartment saying that they have 45 square meters, but it's actually lying. The micro apartments under 9 square meters are really difficult to identify because maybe they will say they have 9 square meters, but that's not the real case. Some buyers and also investors often react too slowly, making things more complicated and also difficult. And also for the government side, it can actually not monitor really easily thousands of listings efficiently to be carrying about like this loi carreste, so under 9 square meters. And so how can AI make the market clearer and also more reliable? Well, in simple words, AI will give us the chance to make everything simpler, but also faster, creating also fairness to this market by turning all this data into just a simple insight, just simple data, easy to read for everyone in the world. So because it can estimate like prices instantly, but also highlight unusual listings, so unusual things in the market. If in the apartment there's a problem, if the price, as I told before, is not that fair, or if you can find something better. So it can reveal actually patterns that you maybe as a human cannot really see. So we're talking about predicting fair prices for any apartment instantly. This by using AI, you can spot overpriced or spot mistakes. You can, the AI can also show you trends, maybe about the future, and it can detect irregular things. And also about all of this, you can actually at the end make faster and more reliable solutions. So at the end, this AI will help us a lot in this business problem. So for our solution, I'll just say a little quick thing. So using these AI-powered price predictions and insights for model real estate decisions. So what we're doing here is that we're using AI we're using the AI and sending them all the data, the historical property listing, this to be able to predict prices for any apartment. So the AI, what it will do is just estimate the values, the price, the features. We're talking about location, the size, how many bathrooms, if they have a balcony, if they have a garage. So all the characteristics. And then what AI will do is just create an output with a reliable output. So we're talking about also about like estimations with a confidence score. This, as I taught before, will make everything faster and making people actually make informed decisions overall.
All right, so let's now talk about the deep, really core of the project, the data strategy, and how we made sure, how we created our model to make sure it was working. So first, we use data sets and labeling and coding. So we combine trusted public data and listing data of the Paris real estate market that we found on Kaggle, and we did the coding on Google Colab. The cleaning and processing actions included deduplications for properties that were listed twice. We handled missing values. For example, if we had missing values on, we didn't know if the property had the number of rooms that we needed or a garage, for example. We also had to normalize features like the square footage. Also, we're going to talk in square meters here because we're talking about the Paris real estate, and transforming everything was too tough and too long to do. So we're going to talk in square meters, but don't worry, I'm going to give you some really insights of what it looks like in square footage, so I'm not losing you. We also extracted information from the announces, and this was carried for characteristics such as boroughs, number of rooms, and renovations. Finally, the validation and analysis plan was made from a random forest regression model fitted with a residual analysis model. So this ensures that we had high accuracy, robustness, stability, and the predictions have a reduced risk of overfitting. We also used TreeShap. So this is an optimized algorithm specifically designed to do explainability frameworks to analyze the results and get insights and also present to you. And finally, we also use regression and visualization to provide clarity and to make sure you understand everything we did properly. So if we run the model, what does it look like on the first try? This is the first data set we ran, so it is 900 properties. And so what you can see here on this diagram, you can see in black, the diagonal dashed line represents the identity line. So it is where the predicted prices of our model would equal the actual prices. All the points you can see are actual properties. Points below the line are points that are undervalued and that are cheaper, than the predicted prices, and points that are higher are more expensive than the predicted value. And you can see in blue the overvalued prices or normally valued prices, but most importantly, here is the sweet spot, is the red dots. These are the undervalued properties. We have 222, so it's a lot. It represents 25% of the properties here, nearly 25%. So, and these represent a 10% difference under the predicted price. So if it's $1 million property, it means you have like a gain of $100,000. So it is a lot. But this is only a first data set. Keep that in mind. So by doing so, the model already got the order of importance of the things it needed to look at, such as the location, the surface area, the agency fees, and the DPE, which is a French thing that stands for Energy Performance Diagnostics. And basically, it is really important because it represents how much you're going to pay for heating, water, stuff like that, and if your property was renovated recently.